Hello friends and welcome to Tech Education YouTube video channel. In today's lecture we will discuss regarding gear trends. What are gear trends, what are different types of gear trends, and where these gear trends are used. This much we will study in today's lecture. In further subsequent lectures we are going to study the problems based on these gear trends. Now let us start. In this gear trend, what is meant by gear trend? First we will study what is gear trend. Sometimes two or more gears are made to mesh with each other to transmit power from one shaft to another shaft. The animation shown here represents a gear trend in which one or more gears are used to transmit power from input shaft to output shaft. This combination is called as a gear train or train of toothed wheels. The nature of train used depends upon the velocity ratio required and the relative position of the axle of the shaft. A gear train may consist of a spur gears, bevel gear, spiral gears, etc. Now the types of gear trains are number of types are there, but from that four important and main types of gear train are there that we will study. First is simple gear train, second compound gear train, third reverted gear train, fourth epicyclic gear train. First we will study what is simple gear train. In simple gear train, a single gear is mounted on one shaft. This type of gear train is called as a simple gear train. On one shaft, one gear is mounted. This type of gear train is called as a simple gear train. Now, in that animation, we are observing that in first animation, we are observing that A and B gear, both are separate gears mounted on two different shafts. Now, first is rotating clockwise, B gear is rotating in anti-clockwise direction, in opposite direction of first gear. The first A gear we will assume it as a driver, and second gear B gear we will assume it as a driven gear. Whereas in second animation we will observe that A gear, first gear is driver gear and second gear B is driven gear. In both animations A is driver and B is driven gear, but we are observing that the diameter of these both gear is different one, isn't it? Now let us assume that A gear is a first gear, which is a driver gear, and B gear is a second gear, which is a driven gear. Therefore, the speed ratio between these two gears can be represented as, or can be given as, N1 upon N2, or it is the ratio of speed of driver gear to the speed of driven gear, isn't it? And it is also equals to the inverse of their number of teeth, that is T2 upon T1. This ratio is speed ratio. For simple gear train, speed ratio is equal to ratio of speed of driver divided by speed of driven gear, isn't it? Now it may be noted that this ratio of speed of driven or follower to the speed of driver is known as a train value. That means reciprocal of speed ratio is a train value, that is N2 upon N1, it is equal to T1 upon T2 is the train value. Remember this for a simple gear train. Now this simple gear train we are observing in many applications. In lathe we can see, or in some various different application we can observe this simple gear train in which a single gear is mounted on a single shaft. Now sometimes the distance between the two gears is very large, or distance between two shaft, input shaft and output shaft, is too much large. The motion from one gear to another gear in such a case may be transmitted by two ways. either of two ways. First way we can use by providing the large size gears. That means suppose in that figure A is the driver gear, C is the driven gear. If suppose I have to transmit power from A to C, I can use first method as the two gears can be made A and C such a large diameter that both will mesh to each other. But this has disadvantage that two larger sized gears are used, which may consume larger area. But because of that, we can use the second method, that is by providing one or more intermediate gears, and these intermediate gears are called as a idler gear. Now let us discuss regarding that idler gear. A little consideration will show that the second method, that is using idler gear, is more convenient and economical. Now it may be noted that when the number of intermediate gears are odd, the motion of both the gears, that is driver and driven, is same. Consider an example as shown in this diagram. A gear and C gear are input and output gears. In between that, I have used odd number gears, that is suppose I have used only one gear. Therefore driver gear will rotate in suppose in anti-clockwise direction, therefore idler gear will rotate in its opposite direction, that is clockwise direction. Therefore to B gear, C gear is in mesh, therefore C gear will rotate in opposite direction of idler gear, that is again in anti-clockwise direction. Therefore input and output shafts are rotating in the same direction because of one idler gear. If such a 3 idler gear you will provide, then also input and output shaft will rotate in same direction. If 5 number of idler gears you are using or intermediate gear you are using, then also you will get the same direction of rotation of input and output shaft. But if you are using even number of intermediate gears, then the motion of driver and driven gear will be in opposite direction. Consider a case in between A and this C gear I am using two intermediate gears. In that case A is rotating suppose anti-clockwise, first intermediate gear will rotate in clockwise, second intermediate gear will rotate in anti-clockwise, and C gear will rotate in clockwise direction. Therefore both the gears will rotate in opposite direction, input and output gears, in case of even number of idler gears, isn't it? Now for this gear train, simple gear train having A, B, C gears or 1, 2, 3 gears, we will find out what is the velocity ratio or speed ratio. What is velocity ratio? We have seen earlier as well, that is velocity of driver divided by velocity of driven, that is N1 upon N2 for first two gears. Suppose A gear is first gear, B gear is second gear, therefore for these two gears velocity ratio will be N1 upon N2. It is equal to T2 upon T1, reciprocal of tooth number of teeth. For second meshed gears, second and third, we will again apply velocity ratio. It will be N2 upon N3 is equal to T3 divided by T2. This will be the velocity ratio for second and third gear. Therefore combinedly multiplying this first equation and second equation, we will get velocity ratio for this total gear train having 1, 2, 3 gears. It will be N1 upon N2 into N2 upon N3 is equal to, in terms of teeth, T2 upon T1 into T3 upon T2. Therefore N2 will get cancelled, T2 will get cancelled, and remaining will be N1 upon N3 is equal to T3 upon T1. That is speed of first gear divided by speed of last gear is equal to number of teeth of last gear divided by number of teeth of first gear, that is N1 upon N3 is equal to T3 upon t1. Same thing, I can write speed ratio is equal to speed of first driver divided by speed of last driven is equal to number of teeth on driven gear divided by number of teeth on driver gear, isn't it? And reciprocal of this speed ratio will be train value. You can identify this train value as a reciprocal of speed ratio. This is regarding idler gear. Now this idler gear is used for two functions generally. First function is to connect the gears where a large center distance is required. Suppose A and C gears are not too much close, they are having large distance, then this gap can be bridged by these idler gears, a number of idler gears. Second function of this idler gear is to obtain the desired direction of motion of the driven gear, isn't it? That means A gear, suppose driver gear and driven gear you want in the same direction, you can use odd number of gears. If suppose you want opposite direction for input and output gear, you can use even number of gears in between driven and driver gear, isn't it? That is regarding idler gear. Second type of gear train we will see is compound gear train. Now observe that animation. In that you are observing that gear A is meshed with gear B. Gear B again is mounted on one shaft. On same shaft gear C is mounted. Gear C is in mesh with gear D. Now from this first animation, black colored animation, you will observe that A is meshed with B, B and C are mounted on same shaft, C is in mesh with D. This type of gear train is called as compound gear train. That means when there is more than one gear on one shaft, such kind of gear train is called as a compound gear train, isn't it? Now whenever the distance between driver and driven or follower has to be bridged over by intermediate gears, at the same time a great speed ratio is required, then the advantage of intermediate gear is intensified by providing compound gears, isn't it, on this intermediate shaft. I will repeat this sentence once again. Whenever the distance between the driver and driven, that is gear A and gear D, has to be bridged by intermediate gears, as well as if we want to increase a large amount of speed ratio, we require large amount of speed ratio also, then the advantage of intermediate gear is intensified by providing compound gears, isn't it? In this case also, each intermediate shaft has two gears rigidly fixed to each other so that they will rotate in the same direction. You can observe in that animation once again, gear A is meshed with B, B and C are mounted on the same shaft, and you can observe B and C gears are rotating in the same direction, that is anti-clockwise direction, isn't it? Now if you want to find out the velocity ratio for this compound gear train, first find out velocity ratio between gear A and B. Velocity ratio is found between the two gears which are in the mesh. A gear is in mesh with B, therefore A gear I will call as a first gear, B gear I will call as second gear, C as third and D as fourth. Therefore velocity ratio between 1 and 2 or A and B is equal to N1 upon N2 is equal to T2 upon T1. Between 3 and 4, that is C and D, velocity ratio is N3 upon N4 is equal to T4 upon T3. And for gear and velocity ratio between 5 and 6 in this diagram will be N5 upon N6 is equal to T6 upon T5. This I have considered a different gear train than that animation. 6 gears are connected to each other, and this 2 and 3 are compound gear, 4 and 5 are also compound gear, transmitting power from first gear to sixth gear. That is, first gear is driver gear, sixth gear is driven gear, and intermediate gears are compound gears. 2 and 3 mounted on same shaft, 4 and 5 gear are mounted on same shaft. This gear train will also be a compound gear train. Therefore, this will velocity ratios between each meshing gear. Then the total velocity ratio for this gear train can be found by multiplying these velocity ratios as n1 upon n2 into n3 upon n4 into n5 upon n6 is equal to, in terms of teeth, you can write. Now cancel out the velocities for gear 2 and 3 because these are mounted on same shaft. These will have the same velocity. n2 and n3 will get cancelled. 4 and 5 gears are mounted on the same shaft, therefore n4 and 5 velocities will also be get cancelled. Therefore remaining velocities will be n1 upon n6. Understand why? Because n4 velocity is equal to n5, n2 velocity is equal to n3, because these are mounted on the same shaft, will have the same velocities. n1 upon nc is equal to now n1 upon n6 is equal to now remaining T2 into T4 into T6 divided by T1 into T3 into T5. This will be the velocity ratio for this gear train. Now this is regarding compound gear train. Now you can put the values of number of teeth and find out the value of velocity ratio. If number of teeth are not given, velocity is given for these gears, and asked to find out velocity ratio, you can find out velocity ratio by dividing n1 divided by n6. This is compound gear train. Third gear train is now reverted gear train. I forgotten to tell you what are the applications of compound gear train. Now this compound gear train you can use where you have to bridge the gap between input and output shaft, as well as you have to reduce or increase the velocity ratio drastically. That means simply I can say a speed reduction in excess of 7:1 can be done by this compound gear train, whereas velocity ratio between less than 7 can be done by simple gear train. This much I can say. Same application for simple and compound gear train, but velocity ratio more than 7 you can achieve by compound gear train. Third type of gear train we'll see as a reverted gear train. Now reverted gear train, you can observe in this diagram, first gear is in mesh with second gear. Second gear and third gear are mounted on same shaft. Third gear is mesh with fourth. But observe carefully, first and fourth gear, that is first gear and last gear, are having the axis which are coaxial shafts, which are having shaft which is coaxial. That is, when the axis of first gear and the last gear are coaxial, then the gear train is called as a reverted gear train. This type of gear train is called as a reverted gear train. In animation also it is shown. See the working. If first gear is rotated, second gear will rotate in its opposite direction. Second gear and third gear are mounted on the same shaft, therefore they will rotate in the same direction with same speed. Third gear is in mesh with fourth gear, therefore fourth gear will rotate, but with different speed. That is, first and fourth gear is in the same axis, but they are rotating with different speed. The application for this reverted gear train will be the minute and hour hand or minute and second hand of the wristwatch. In that wristwatch you can observe the minute hand is rotating with different speed than the second hand and hour hand is rotating with different speed, but all hands are coaxial. This can be done by this reverted gear train. Now, again, one more interesting thing regarding reverted gear train we can see as the distance between the centers of shaft of gear 1 and 2 as well as between gear 3 and 4. Observe carefully distance between these shafts. Which shafts? For gear 1 and 2 and for gear 3 and 4. This distance is the same. Therefore, I can write one relationship like that. R1 plus R2, radius of gear 1 plus radius of gear 2 is equal to radius of gear 3 plus radius of gear 4. This equation I can write. Now, this equation, that is R1 plus R2 is equal to R3 plus R4, I can write directly in terms of number of teeth, that is T1 plus T2 is equal to T3 plus T4. How I can write? Because the circular pitch or module of all gear is assumed as the same. If suppose two gears are in mesh, remember that the circular pitch or module of these two gear will be same. Therefore, here for gear 1 and 2, for 3 and 4, circular pitch and module will be same. Therefore, I can convert this radius in terms of teeth directly, that is T1 plus T2 is equal to T3 plus T4. Remember this because while solving problem we are requiring these relations. I can write by looking into geometry relation in terms of radius or in terms of diameter and directly convert in terms of teeth. In some problems, some number of teeth are given for some gears, and for some gear we will find out by using this kind of geometric relationship, isn't it? Now, for speed ratio, again speed ratio for this reverted gear train we can find by product of number of teeth on driven gear divided by product of number of teeth on driver gear, same as that of compound gear train, because this is also compound gear train. Why? Because in this 2 and 3 gears are mounted on the same shaft. Therefore, this reverted gear train can be considered as a compound gear train also. But difference is what? In reverted gear train, input and output shaft are coaxial. Now, application for this, more application for this reverted gear train will be lathe back gear, industrial speed reducers, in automobile transmission, and in clocks we are using this reverted gear train. Next is epicyclic gear train. In epicyclic gear train, such kind of arrangement is there, that is A gear is in mesh with B, but A gear and B gear are connected by one arm, that is two axes of these A and B gear, that is O1 and O2 are connected by one arm. The definition for this I can quote as, suppose epicyclic gear train is a gear train in which one gear can rotate about, or one gear can rotate around the another gear. In animation we can say that B gear is rotating about itself as well as about some another gear as gear A. This is because these two gear axes are connected by one arm. In previous whatever we have seen the types, simple, compound, reverted gear train, the shaft of all gear is fixed. The shafts are not rotating. But in this case of epicyclic gear train, the shafts of gear can be rotated or are rotating about some another fixed shaft. In that animation you observe that suppose that smaller gear is A and larger gear is B, that A gear is having fixed shaft, whereas B gear is rotating around the A gear with that shaft O2. Another combination may be like this: the O2 shaft will be fixed and O1 shaft is rotating around the O2 shaft. This case is also possible in case of epicyclic gear train. Now for this epicyclic gear train, n number of applications are there. Epicyclic gear train are useful for transmitting high velocity ratios with the gears of moderate size in a comparatively lesser space. The epicyclic gear train are used in the back gear of the lathe, differential gears of automobiles, hoists, pulley blocks, wristwatches also. Now, these epicyclic gear train are used generally in the sun and planet type of gear trains as well. That is nothing but sun and planet type of epicyclic gear trains are possible. Some examples of this sun and planet type of gear trains I have shown here. What is the geometry of that sun and planet type of gear train? I will show by this second animation. In that, observe that whatever central gear is there in all animation is called as sun gear. Whatever outer gear is there, which is having inner side teeth, is called as annular gear, and whatever gears are rotating around the sun are called as a planet gears, and those planet gears are carried by a carrier. Understand the geometry: sun gear, planet gears, annular gears. Planet gears and sun gear can be attached by a carrier. These all are the types of sun and planet type of epicyclic gear train. These trains are epicyclic gear train. Why I have shown this? Because while solving some problems, you may observe this type of epicyclic gear trains as well. Now, there is one method to find out velocity ratios or velocities for this type of gears. There is no such a velocity ratio formula whatever we have seen previously for simple, compound and reverted gear train. Here one different tabular method is used. This tabular method and some problems we will see in the next video. So comment on this video whatever I have discussed in this video. Would you like it? And subscribe to my channel. Thanks for watching. Stay tuned for the next videos. Thank you.